All right, good day. Hope that you're doing good. So in this video, we're going to be looking into tangents to a graph. Basically, we're going to look into how can you solve questions relating to tangents to a graph, right? As well as the steps you need to go about taking whenever you have a question relating to a tangent to a graph. Now, first, we're going to start off with the steps for solving questions relating to tangents to a graph. Now, what is the first step? First step is that you need to find your point of interception. Now, what is your point of interception? This is a point whereby your tangent and your graph share. Now, remember, your tangent only touches your graph at one point. Now, if I were to make a rough representation of that, so let me just draw these are my x's. See, this is my graph, and this is my other graph. Now, what I'm saying is that a tangent only touches your graph at only one point, right? And we need to find that point, which is our point of interception. We need to find the coordinates of this point, right? Now, second step, this tangent right over here, it is a straight line, meaning that it can be written in the form of y is equals to mx plus c, right? So the second step is that, let's say you are asked to determine the equation of your tangent, right? So step two, you need to find, so step two, you need to find the gradient of your tangent. Now, as I was saying, if they ask you to determine the equation of your line, which is a tangent to your graph, first you need to find your point of interception. Secondly, you need to find the gradient of your tangent. Now, how would you go about finding the gradient of your tangent? Now, always the gradient of your tangent, you would need to take your first derivative, right? And on this equation of your first derivative, you're going to substitute the x value of your point of interception. Now, let's say our point of interception, we found these two coordinates, 2 and 4. And this is our graph, 2x squared minus 4x, right? I'm saying to find the gradient of the tangent to this graph, you would need to take the first derivative of this graph, which would be 4x minus 4. And where there is x, you're going to substitute the x value of your point of interception, which is this x value right over here. So this would be 4 multiplied by 2 minus 4, meaning that my m in this case would be equals to 4. Now, this is how you find the gradient of your tangent. You take the first derivative of your graph and you substitute the x value of your point of interception. Now, with regards to step 3, remember your graph must be in a form of the equation of your line must be in a form of y is equals to mx plus c. You already determined your value of m. What about determining your value of c? So to determine the value of c, which is the third step, so here we are determining the value of c. Now, what is c? C is the y-intercept of your straight line graph, right? Now, how would we go about doing this? So we're going to take, so we are going to take our straight line equation, and from there we're going to substitute our value of m as well as our point of interception. So now for the final step, right? To determine the value of c, remember now these are the steps, by the way, you need to go about to finding the equation of your straight line, which is a tangent to your graph. So first step, you find this point of interception. Secondly, you find the gradient, which is m, and this is how you go about finding the gradient. Step c, which is finding this value of c. So how are you going to do that? So you're going to take your straight line equation, which is your y is equals to mx plus c, and you're going to substitute the value of m, right, that you've calculated before, and then you're going to substitute the x and y values of your point of interception, which is this point right over here. From there, you're going to find your value of c. Now, I want us to look into typical exam questions which relates to a tangent of your graph, right? So now let us start off with the first question. Now, starting off with the first question, they say determine the equation of a tangent to the original function g of x, which is given as x cubed minus 3x at x is equals to 3. right? So we're trying to determine the equation of a tangent. And remember, your tangent, it will be a straight line, which should be in the form of y is equals to mx plus c. Now remember, step one. Step one, we said you need to find your point of interception, right? So starting off with step one, which is finding our point of interception. Now I'm told that this tangent, it is a tangent to this function of g of x at x is equals to 3. So I already have the x value whereby both these graphs meet. So my x value is at 3. Now, how would I find the corresponding y value? I will just simply substitute this 3 into the original equation to find my y. So 3 cubed minus 3 multiplied by 3. And this would be equals to my y. Now, 3 cubed is equals to 27. 3 multiplied by 3 is equals to 9. 27 minus 9, this is equals to 18. So I know that the y value here, it will be at 18. Now, I did step one, which is finding my point of intercepting, right? So I did step one, which is finding my point of interception, which is at 3 and 18. Now, step two. Now remember step two, now I need to find what? You need to find your gradient of your tangent. Now, how would we go about finding our gradient? Remember, we need to find the first derivative. And from there, we're going to sub the x value of our interception point. Now, let us find the first derivative of g of x. So it will be this 3 multiplied to the coefficient of x, which is 1. So this is 3x. Remember, on your exponent, you would subtract 1. And here, the derivative of 3x is the same, or the derivative of minus 3x is the same as minus 3. So as a result, my inverse here, it will be equals to 3x squared minus 3. Now, this is the first derivative. And remember, I said on this first derivative, I need to substitute the x value of my point of interception, which is 3. So basically, substituting that, I'm going to find my value of m, which is my gradient. So 3 multiplied to 3 squared minus 3. This would give me my value of m, which is my gradient. Now, punching this into your calculator, your gradient would be equals to 24. So now, you solve for your m. Remember, your equation is y is equals to mx plus c. You find your value of m, which is 24, right? Now we need to find our value of c, right? Which would be step 3. Remember, step 3 is finding the y-intercept, which is your value of c for your tangent. So now step 3, we need to find c. Now I said we're going to use this y is equals to mx plus c equation. And to find c, we're going to substitute our m, which we've calculated as 24. With regards to the x and y value, we're going to substitute the x and y value of our point of interception, which is this point right over here. So my y is equals to 18. My x is equals to 3. And plus c. So 24 multiplied by 3, this would be equals to 72. So 18 is equals to 72 plus c. And now taking this to the other side, my c would be equals to negative 72 plus 18, which would be equals to negative 54. Right. Now, finally, I can now write down my equation as y is equals to my m, which is 24, x, and my value of c, which is minus 54. Now, this would be the equation of the tangent to this graph, which is x cubed minus 3x. Now, let us look into the preceding question. Now, for the preceding question, if h of x is equals to negative x plus p is a tangent to f of x, now your f of x is equals to negative x, so this is supposed to be squared, negative x squared plus 3x plus 4. Now, we need to find the value of p. Now, remember, these questions are from your previous exam question papers, right? So now, what is p? If h of x is a tangent, remember, what is the equation of your tangent? Your equation of a tangent is in the form of y is equals to mx plus c. Now, your gradient is whatever value that is attached to your x. And here you can see that here, negative 1, which is invisible, is attached to our x. So we know that, okay, our gradient of this line of h of x is negative 1. P, it is our value of c, which is the y-intercept. And remember, how do we go about finding the value of c? It's by using the straight line equation, right? Remember the step. We're going to use the straight line equation and we're going to substitute our value of m. So we already have our value of m, right? Now here, as well as our point of interception. So step 3, which is what we're going to make reference to. Remember, we need to sub our value of m and our point of interception. Now, our m, It's whatever value that is attached to our x. In this case, our m is -1. Now, do I have my point of interception? I do not have my point of interception, meaning that if I could find my point of interception, then I could be able to find my value of p, because this is the only thing that I need to solve for p. Now, how would I find my point of interception making use of the information that I have? Now, if I know that my gradient is equal to -1, remember I'm trying to find this point of interception. Now I'm going to make use of what I have. Now I have my gradient. I can make use of step 2. Now remember, how did they find this gradient? They took the first derivative of f of x, and then they did what? They substituted the x value of my point of interception, which is this value I'm looking for right over here. So making use of this step, I can calculate this x value. How would I do that? First, let me find the first derivative, which would be equal to -2x plus 3. And I said, when they substituted this x value of my point of interception, they got a gradient of -1. So I can solve for x. So taking the 3 to the other side, I would have -2x is equals to, this would become a negative, -3, -1. This would be -4. Dividing both sides by -2, my x would be equals to +2. Now, when they substituted +2, they got a gradient of -1 on my first derivative. Now remember, this x value that they substituted is the x value of my point of interception. So I know that the x here, it will be equals to 2. Now, what about finding the corresponding y value? We can just take this 2 and substitute it to the original equation, right? Y is equals to -2 squared plus 3 multiplied by 2 plus 4, right? And punching that into my calculator, my y, it would be equals to 6. So I know that my point of interception is at 2 and 6. And I know that my gradient is equals to -1. Remember, the only thing that I needed is this point of interception to find my value of p, right? Which is using step 3. Now, I have my gradient. So my m is equals to -1. My point of interception is at 2 and 6. Now, I can find the equation of the tangent, right? And now I can solve for my p. Now, remember the equation of my tangent, it's, let me see, h of x, it is equals to -x plus p. So this is the same as y is equals to -x plus p, right? So my y, I'm going to substitute my y here, which is at 6, and -1 is my gradient, remember, multiplied to my x, which is 2. Now I can solve for my value of p. So 6, it is equals to -2 plus p, so that my value of p would be equals to 8. Right. Now, can you see that we have still used the very same steps, right? You still need to use the very same steps to solve for whatever question they're asking you. We still use these steps to determine our value of p, right? It's just that now we weren't working from step 1, 2, and then 3. We didn't work in a particular order, but then we still use the very same steps to find our value of p.